Welcome to our demo of CodeTuner for Cloud. It's great to have all of you here, and I'm very excited to share our new tool that is designed especially for optimizing your cloud costs at the code level. Over the next half hour, I'll take you through a demo of our latest cloud cost optimization tool. And at the end, we'll have time for a Q&A session. Please put any questions either in the Zoom chat here or on LinkedIn, and we will address them at the end of the session. So before we dive into the tool, a few words about myself and about the team behind CodeTuner. My name is Jordan, and I will be your host today. And I have been a part of the product science team for over 2 years now, starting with our first product focused on mobile. I work with our enterprise clients, providing support, facilitating trainings, and creating insight reports whenever needed. And I also work closely with our developers, helping to test and craft the tools that engineers truly appreciate. And if you ever have questions about our tooling, feel free to contact me, and I will have my contact details at the end of this presentation. At Product Science, we are a diverse and dynamic team, passionate about enabling engineers to write the most efficient code. Our core technology captures everything that happens in your code, including any dependencies and all of the processes that are happening in parallel to provide unique visibility and insight into any inefficiencies that might exist there. And simply by having this visibility into what is really happening in the code, it brings clarity into what and how you can optimize and where you can spend your time and your effort. And this insight into the code really affects everything about your product. And the area where the impact can be the most noticeable is in reducing cloud spending. So here is a sneak peek of where we will go with this demo, and we'll get to see how CodeTuner for Cloud can show you everything related to your cloud costs and how it relates to your code. But before that, let's talk a bit about the problem around cloud costs and how our technology offers an efficient solution. These days, cloud is essential for any business. However, for most of them, cloud costs are rising out of control. The most obvious methods of cloud cost optimization have been exhausted, and current CCO tools on the market are outdated. And now, in order to cut these costs, companies are forced to either cut projects and features or to reduce the quality of their output. There are processes and techniques developed to address the cloud cost problem, yet it persists. And this is because we are not addressing the issue at its source, which is the code. Up until now, cloud cost management solutions have provided visibility into resource usage, where they'd recommend you to adjust usage of credits and promotions. However, once you exhaust these options, there isn't much more you can do with the data that is available to you. You can't just cut traffic because you need to use your servers to maintain functionality. So to make an informed optimization decision, you need to see where exactly these optimizations can be made. And for that, you eventually need to analyze the cost from its source. And this is where CodeTuner comes into play. So what is so special about CodeTuner? CodeTuner for Cloud focuses on identifying the source of your cloud costs by capturing all cloud events on the code level. It reveals the real costs associated with each call, including all hidden costs, and we'll explain more examples of this throughout the demo. Other CCO tools often lack this visibility, focusing instead on higher level architectural resource usage insights, which leads to incomplete and misinformed decisions. CodeTuner allows you to focus on the cloud cost savings you can achieve directly by optimizing your code. And CodeTuner sets itself apart from other CCO tools because it was specifically crafted with engineers and engineering managers in mind. For example, by analyzing cloud spending at the code level, engineers can identify specific lines of code or components that are driving up costs. This allows for targeted optimizations such as refactoring inefficient code or adjusting resource allocation. Additionally, with detailed insights into how specific code changes affect cloud spending, engineering managers can better predict future costs based on planned development work. This helps in creating more accurate budgets and avoiding unexpected cost overruns. I will provide more examples of how CodeTuner can help to streamline development and increase collaboration and productivity later on in this demo. But simply put, if cloud costs is an essential problem for your business, you've probably tried dozens of different tools and approaches, gotten as much as you could from them, and now you are fighting for each % of your potential savings. Addressing and optimizing your code with the focus on cloud spending can easily save you as much as 20% of your cloud costs by targeting the issues you previously had no visibility into. Now, let's explore these hidden costs and see how CodeTuner can help you understand and reduce them. So with CodeTuner, you have 3 main views that uncover insights about your spending on different levels. I'll briefly go over the main features of each view, and then we'll see it in action in the tool. The most general dashboard view provides a consolidated view of your spending and quickly helps to understand your most expensive calls. So this is a screenshot here on the slide that we see of the dashboard view. And this is also the place where you'll get all of your notifications about spikes in your resource usage and any unexpected behavior. The consolidated data that you can see here probably looks familiar, and what really shows the difference is the next 2 views, which provide detailed information in the context of user sessions. For each API endpoint, you can select a specific user session where this API was called. And this gives you valuable insight into the sequence and context of API calls when a real user is actually utilizing your product. And when you see when you open a particular user session, you'll see details of all API calls within that session. And you can see a breakdown by direct and indirect calls. So we see that here on the screen. We have some of the calls labeled direct, while others are labeled indirect. And indirect calls normally create the most traffic and are often the biggest contributor to cloud spendings, whereas direct calls are the straightforward API requests that are triggered synchronously by a user action or some sort of interaction within the app. And unlike CodeTuner for cloud, most tools on the market lack visibility into which particular code events are contributing to your largest spending. So as an example here, again on the slide, we see that we have a cloud SQL query marked as a direct call, but on the other hand, we have other cloud functions and calls to storage that are marked as indirect, and again, are triggered asynchronously. So this view already gives you better context into how exactly each of these expensive API calls correlates with the user experience. And we'll get a better understanding of this when everything is visualized on the trace file. So here we have the trace view, and this is the heart and soul of CodeTuner. And this view visualizes all the code events executed during a user session that contributes to your cloud costs. And it also highlights all of the asynchronous dependencies between them. So CodeTuner allows you to capture all code events automatically with no extra effort on your side and no manual instrumentation. We use machine learning to find the sweet spot of capturing and showing everything that matters for cloud cost optimization while not overwhelming the view and not impacting performance. When an endpoint is called, you'd see a single direct call. And in this example on the slide here, it is a small post traces query. And this is taking about 1 millisecond to execute. But once this endpoint is called, it can trigger additional events such as SQL queries, serverless functions, storage requests, and AI model inferences, all of which have associated costs that are often missed in endpoint cost calculations. So here you're able to see how the post traces query triggers a much larger chain of asynchronous events, including uploading of data to Google Cloud Storage, cloud functions, logging, as well as other unrelated events that may be happening in parallel. So with other tools, you'd see your spending on the resource level. And for example, you'd still see that database or storage was accessed. But without the ability to relate this resource usage directly to the code, you're forced to operate in the dark and guess which of the code changes will actually impact your spending. With CodeTuner's capabilities, you know which specific method is responsible for even the tiniest spending, as well as the logic behind its execution. Knowing that logic, you can quickly reassess and optimize it. Simply just click on any method on the trace file and see the chain of events that triggered it. So with all this information, let's get into the tool. So now I'll go to the tool to demonstrate CodeTuner for Cloud's capabilities in revealing cloud cost optimizations. So right now what you're seeing is the dashboard view, which again shows an overview of CPU and storage usage along with traffic and activity. So here we see the API endpoints listed. And by selecting an endpoint, I'll go ahead and select this one. CodeTuner shows a breakdown of all the calls that are hitting that endpoint. And of course, we can expand the list and see all of the calls that hit that endpoint. And for each endpoint and call, CodeTuner also shows CPU time, storage, traffic, and count. And this is shown as a total amount and also as an average amount per user session. And we also have the cost section here, which then allows you to see how that contributes to your cloud costs. So thus you can see how your code actually translates to your real costs. And as mentioned previously, most CCO tools lack the visibility into how indirect calls contribute to your hidden cloud costs. So if I go to the cost section here, let's say we choose the most expensive endpoint from the list. So if I select this endpoint here, this looks to be the most expensive. We can now, again, see all the calls that are hitting that endpoint. And we notice here that when I expand the list and continue to scroll and continue to scroll, we actually don't see the first direct call until we've scrolled pretty far down this list. So that just highlights that it's not always the direct calls that are contributing to the most to your cloud costs. In most cases, it's actually the indirect calls that are making the biggest impact as far as cloud spending goes. So this just goes to show how important it is and the value that CodeTuner for Cloud provides by showing you both the indirect and indirect calls that are hitting the endpoint, so you can really get an overview of everything that is contributing to your code, to your cloud costs. And this example, again, just highlights the importance of having the full visibility and going straight to the source of your code when you're making these cloud cost optimizations and trying to figure out, where to focus your efforts. So scrolling back up to the indirect calls, for each of these indirect calls, there is an original direct call that triggered it. And this allows you to relate certain events to see what was happening in the process so that you can make any, again, necessary optimizations there. So the dashboard view gives an overview of your most expensive endpoints and helps you to focus your attention for further analysis. And for this analysis, once you know where to focus your attention, the next step is to select a user session. And for each endpoint, you can select one of the user sessions that will lead you to the user session view. So again, we have this post traces endpoint. I will scroll down and here we see the user sessions. So I can just select the first session here. And the user session view provides context about how a user was using your app and any actions they completed and which endpoints were involved. So what is key about the user session view? Focusing on the user session helps to ensure that any optimizations made to address cloud storage and costs do not negatively impact user experience with the app. Ideally, the goal here is to maintain or improve user experience while reducing cloud costs. The user sessions view shows a roadmap of which calls were made, which endpoints were hit in what order, and what was happening in the cloud as a result of a user's interaction with the app. And so here again, we see all of the calls that are made and in what order and what endpoints were hit. And by selecting the view session in trace from the user session view, that will actually open up the trace view, which we can see right here. So the trace view is an element from our original core product for mobile performance optimization. And on the trace file, we see all of the methods that are executed in the code during a user session. And these methods are shown here as slices. And each different color slice corresponds to a different method or process that is occurring during the user session. And we can also see which thread each method belongs to with the thread names here on the left. So in white here, we have all of the various thread names that these methods are being executed in. And scrolling up and down also reveals all of the methods and processes occurring that are at the same time in parallel threads. So we can see any additional processes that are happening just by scrolling through the trace file. And so the horizontal axis of the trace view and also the length of a slice correspond to the time and the amount of time it takes to execute that slice or method. So again, we have the timeline here that's showing the amount of time it takes to execute this user session, but we also have here the length of the slices. So again, the longer the slice, the longer it took to execute compared to these other slices here. And we also see here on this trace view, this yellow line that is connecting the slices here. And this yellow line creates the execution path, which shows the dependencies between the methods and processes that are executed during a user session. So this basically shows which process triggered the next. So we see this process was triggered by the process that occurred before it, which was triggered by the processes that occur before it, and that's how we read the execution path. So again, it just shows the progression of calls that were made, leading in the selected result. So clicking outside of the execution path in the trace, if I were to click here, deselects the main execution path. And if I want to get the path back, I will just select the slice from where we created the path, which was this slice here, this cloud function. So that's how you get your path. And each slice on the trace view will have its own execution path. So it changes depending on which slice is selected. And right now we see the path for this, this method here. So zooming into the path, we see here that we have a cloud function. We have another cloud function here. And we see that this was triggered by a call to storage. And that takes us to the beginning of the path, where we actually see the direct post traces call. So here we have beginning of the trace, and we see the post traces call. And then we also see this upload trace here, which what we're seeing in this user session was when a user had uploaded a trace. So that was the action that kind of kicked off this whole process. But we see again the direct call right here. So the tool shows that we started with the post traces event, where a trace file was uploaded to storage, and that data was then passed to Google Cloud. And overall, with this example, we see that although the direct call, which again here, is pretty small, meaning that it takes the least amount of time, and it is what triggers this chain of events. But we see that although the direct call is not taking much time, the events that were triggered as a result of this call are what takes up more time here. So it just highlights that, the direct calls are just kind of the surface, and CodeTuner allows you to go below the surface to see everything that's happening with your cloud costs and your cloud storage. And this just provides additional visibility that is not available with other tools. So with a few clicks, you can select a method and you can see its execution path, while our automatic instrumentation reveals the methods involved in the process and what class they belong to. This way, the methods can be located in the code base and also within any third-party libraries and frameworks. And this provides context into why each resource was used and the purpose. And also, if you want to see the number of events triggered from a specific user action and the overall resources used, you can actually go straight to the direct call and select it. So again, right now we have the path from this cloud function, but if I select this direct call here, and I switch the direction of the path, we now see the processes from here, which this pretty much shows a similar view of what we just saw, which it should, because before we were looking at the path in the backwards direction from this cloud function, and now we're looking in the forwards direction from the direct call. So this just shows that you can see the path going both directions from where it ends up and also from where it starts. So now that we are more familiar with the tool and all of the views, the dashboard view, the user session view, and now the trace view, I will go ahead and share an example of an inefficiency from our own backend that we found using CodeTuner for Cloud. The real-life example that we caught on our own backend that I just mentioned comes from overusing our server when uploading data to be processed on Google Cloud. Before, a user's action would trigger a post-trace query that itself started uploading data to our server. Once that was complete, the data was uploaded from our server to the cloud. This way, we were using 3 times the traffic, once for uploading data to our server, once for uploading it from the server to the cloud on the server side, and then once on the cloud side. So by substituting the server uploading process with a request for cloud link to upload the data directly there, we save close to 50% of traffic on this operation. And this is a pretty simple example, but it provides a good illustration of how a trace file looks and how you can identify and address issues quickly using CodeTuner. And this kind of inefficiency can happen to anyone, and inefficiencies like this will continue to happen. But the point is not to avoid inefficiencies completely, but to be able to catch and fix them quickly, even if they happen to be in some ancient legacy code. So being able to relate a method from your code base to the associated spending is what makes cloud cost optimization easy and straightforward with CodeTuner, and a valuable tool for both managers and engineers. In addition to the example from our own backend, I will quickly share an example that we often see with clients. The story behind this example is that when a user is using an app and initiates a search, multiple requests are sent to prefetch search results. But then when more search parameters are specified, for example, maybe some search filters are applied, the outdated initial requests that were sent were not canceled when a new updated request was sent to fetch the search results based on the new filters that are applied. So this example highlights the unparalleled visibility and insight that CodeTuner for Cloud provides into your cloud usage and spending, because you can literally see exactly what's going on in your code and how every method in your code is directly contributing to your cloud costs. And also having the visibility on the trace viewer gives you further insight into what optimizations should be made and where. So hopefully by now, after these additional examples, you are as excited about CodeTuner and its capabilities as I am. So now that I've demonstrated the capabilities of CodeTuner for Cloud, I just want to end by highlighting how this tool will improve and streamline the workflow of managers and engineers. By providing visibility into how different parts of an app are consuming resources, CodeTuner for Cloud provides better alignment between resource allocation and actual usage. So this can help with right-sizing cloud infrastructure. And CodeTuner also prevents resource waste by monitoring resource usage at the code level. CodeTuner can alert teams to underutilized or idle resources, helping them to eliminate waste and to better allocate their resources. CodeTuner also helps to speed up development cycles by providing visibility into how code changes impact cloud costs and resource usage. Teams can receive immediate feedback, which allows them to iterate faster and make informed decisions without waiting for cost analysis reports. Additionally, continuous monitoring and optimization reduce the likelihood of accruing technical debt related to cloud infrastructure, leading to smoother development and deployment processes. CodeTuner also supports strategic decision-making because engineering managers are able to use CodeTuner to manage cloud budgets more effectively and efficiently, ensuring that spending stays within limits and aligning costs with business goals. And with clear visibility into the cost impact of different code components, teams can prioritize work on features or optimizations that offer the greatest return on investment. And lastly, CodeTuner provides a shared understanding of cloud costs across development, operations, and finance teams, fostering better collaboration and decision-making. And by linking technical decisions to financial outcomes, engineering managers can better align engineering efforts with broader business objectives. So this level of visibility not only helps in reducing cloud costs, but also streamlines development processes, improves code quality, and enhances overall productivity. So this brings us to the end of the demo. I hope you enjoyed getting to know more about CodeTuner for Cloud. And of course, let's stay in touch. You can contact me via LinkedIn or email to set up everything that you need to use CodeTuner for your team's needs. And we also have some time left for questions. So if you haven't yet posted your question, now is a great time to do so. And I do see to here. So the first question is, what languages and cloud providers do you support? So right now, we have a release version for JVM and beta versions for .NET and Node.js. And our approach is language agnostic and has been from the beginning, starting with our original tool for mobile. So we quickly adopt new languages, and we support Python, and support for Go is in development. And we work with all cloud providers. And then a second question here, is there a way to tell which team the cost is attributed to, so we know which team would be responsible for addressing and optimizing these costs? So yes, although the data is grouped in terms of API calls, we also show particular classes in your code base that contribute to the cost. So when you know the exact class, it may also be the case that you know which team this class is attributed to. And additionally, the trace viewer allows you to go deeper to see the trace file for the selected endpoint, which shows the process that triggered the endpoint and where it was processed. So this visibility allows you to determine which team the cost is attributed to. And I think that was all for questions. So again, thank you all for joining. I hope you enjoyed this demo of CodeTuner for Cloud. And again, feel free to reach out to me on LinkedIn or via email. We would love to get you started with CodeTuner.